The first thing we're going to do in section 7.5 is review cross multiply, because you will have to do that at least once on your assignment, maybe twice on your assignment, and there will probably be at least one question on the test that involves cross multiply. So anytime that you have fraction equals fraction, that's when you're allowed to cross multiply. And before you cross multiply, it is a good idea to put parentheses around any numerator or denominator that contains addition or subtraction. When we cross multiply, we do top left times bottom right, so 2x equals 1 times x squared minus x. If we simplify that, if we simplify that, we've got 2x equals x squared minus x. We need to get 0 on one side because we have x's and numbers. So I'm going to subtract 2x on both sides to get 0 equals x squared minus 3x. This is only two terms. How do we factor something that's only two terms? What do those two terms have in common? X. So pull x outside of the parentheses and then pull an x out of each of those terms. X squared, if you take an x out, is just x. Negative 3x, if you take an x out, is negative 3. Which means our solutions are 3. Imagine that this has its own set of parentheses. 0. We've got 0 and 3. Now we have to go back to the original problem because we need to make sure that the denominators are not going to be 0. So if I take x equals 0 and plug it in right here, we would have 1 divided by 0. That's no good, so that's an extraneous solution. You don't even have to check both denominators, but if it makes 0 in any of the denominators, it's not going to work. Now let's check 3. If I put 3 in right here, we're good. That'd be 1/3. If I put 3 in here, 3 squared is 9 minus 3. That's definitely not 0. So our answer of 3 is good. Okay, when we approach this type, this is not fraction equals fraction. There's extra terms in here, so we're going to have to use a different tactic. I like to rewrite the problem, spreading it out, and factoring any denominators that we may need to factor. X plus 3 is good. I'm just going to put it in parentheses. I'm going to give myself some space. 1, give myself some space. And anytime that you see subtraction, change that to plus a negative. Okay, so really, I haven't changed anything yet. I've just spaced out what I've got. Oh, yeah. Thank you to my first hour class for noticing that I forgot the X on the top. Okay. All right, what denominators do you see in this problem? X plus 3. The only denominator is x plus 3. I am going to multiply the top of everything by x plus 3. This is like, I'll do this in gray over here. If I had x plus 2 equals 5. 3 plus 2 is 5, right? So x is 3. If I multiply everything by 2, I've got 2x plus 6 equals 10. My answer here is still, 2x plus 4 equals 10. My answer here is still x equals 3. You can multiply every single term in an equation by something. In this case, I multiplied everything by 2. Here, we're multiplying everything by x plus 3. Okay, here's the beautiful thing that happens. In this first fraction, the x plus 3's cancel. We're left with just 2x. equals. In the next term, nothing cancels, but we would distribute. In this case, it just becomes x plus 3. And in the final term, the x plus 3 cancels, and we're left with plus a negative 6, which would just be minus 6. Does this look like an equation that you know how to solve? Yeah, we've got 2x equals x minus 3, subtract x on both sides, x equals negative 3. So I have to be careful what I say on the video, but basically our goal here is to make the fractions go away, to slash those fractions so that all that's left is stuff that isn't fractions and easy to solve. Now with all of these solving problems, when you get to the end, you do need to check, would my answer create a 0 in the denominator of the original problem? What is negative 3 plus 3? 0. Well, shoot. So this answer doesn't actually work, which means that there are no solutions. So yeah, this is a little bit frustrating. We did all that work and it ends up just being no solutions, but we wouldn't know that unless we had done the work. The first thing that I want to do in number 4 is space things out and factor anything that can be factored. On the bottom here, x minus 2 is basically done. Leave myself a nice space. 6 over, can x squared minus 4 be factored? That's a difference of 2 squares. It factors into x plus 2, x minus 2. And then leave a space, and we've got plus 1. Okay, what denominators do you see in this problem? We've got the x minus 2, and we've got x plus 2. It's okay if you have 2 x minus 2s, you only need to use it once. So sometimes I call this, what distinct denominators do you have? Like what factors do you have in the denominator, but don't include any repeats? So we've got x minus 2 and we've got x plus 2. So I'm going to multiply by x minus 2, x plus 2. Do you see why I space it out? Multiply every single term in the equation by those denominators, x minus 2 and x plus 2. Then we get to slash the fractions. In the first term, x minus 2 cancels. We're left with 3x minus 2 times x plus 2. That is going to involve some double distribution. But in the next term, what cancels? X plus 2 cancels, x minus 2 cancels, you're left with 6. And then this last one, you do have to do x plus 2 times x minus 2. So there's a little bit of work here that we have to do, but at least the fractions are gone. So, do you feel fairly confident double distributing and simplifying this? Pause the video, double distribute, FOIL, whatever you call it, try to combine your like terms, and then play the video. We'll see where we're at that point. I double distributed on both sides, combined all of my like terms, and then because there's x squared and x, I'm getting everything over to the left side, trying to keep my x squared positive. When I get to this point, I get a little bit nervous because there's a 2 in front of my x squared. But what do you notice about all 3 of these terms? They're all even. We can divide everything by 2 so that we just have x squared plus 2x minus 3. And that is something that we hopefully know how to factor. So we're looking for two numbers that multiply to give us negative 3. It's probably 1 and 3. They have to add up to positive 2. So that's going to be, a positive 3 and a minus 1. So x minus 1, x plus 3 is the factored form. Why are you moving around on me? So our solutions are 1 and negative 3. Positive 1 and negative 3 are our solutions. Let's go back to the original problem. One minus 2 and 1 squared minus 4, neither of those are going to create 0, so x equals 1 is good. Negative 3 minus 2 is not 0. Negative 3 squared minus 4 is not 0, so that answer is also good. Both of those answers are going to work just fine in this problem. If you get out your worksheet, worksheet 8, we are going to do numbers 9, 11, and 13 together. So get out your worksheet and look at number 9. Normally I would say to break up that 4 into 2 times 2, but I think in this case it's actually going to help us out if we just leave it as 4. So what denominators do we see? We've got 2, we've got x, and we've got 4. So I'm going to multiply everything by 2 and x and 4. Okay? So times 2 times 4 times x times 2 times 4 times x times 2 times 4 times x. Okay, now we play the, should we call it the slashing game? Is that a good name for it? The 2 cancels, the x cancels. You're left with 5 times 4, which is 20. Then there's a plus sign. The 4 cancels. You're left with 1 times 2 times x, so that would be 2x. The 2 cancels, the x cancels, you're left with 9 times 4, which is 36. Do you feel like that's an equation that you would know how to finish solving completely on your own? I think so. Number 11 looks like this. I have just spaced it out and I put parentheses around anything that had addition or subtraction. Nothing here needs to be factored. So I need to think about what are the denominators. My denominators are x minus 5 and x. So that's what we're going to multiply everything by. X minus 5 times x, x minus 5 times x, x minus 5 times x. I guess I didn't really need it like that. The slashing game. X minus 5 cancels. We're left with 4x. In the next term, x cancels. We're left with x minus 5. After the equals sign, x minus 5 cancels. We are left with x times x minus 1. I just put the x in front of the parentheses to make later distribution easier. So if we combine our like terms, how would we solve this one? We would need to get 0 on one side so that we can factor and solve. So 0 equals x squared. We're subtracting 5x on both sides, so we have minus 6x. And we're adding 5 on both sides, plus 5. You would need to factor and solve and check your solution. Okay, here's number 13. I'm showing you snippets of number 13 because I'm running out of time on the video, so pause to get this part and then I'll show a snippet toward the end. Here's the answer to number 13. We now have done 9, 11, and 13. I want you to pick 8 more to do.